Hello everyone, this is the solution for problem 2 in homework 2. So for the first part of this problem, what we need is the probability of the event x2 equals 1. So from the Bayes theorem, it is easy to know that this is equal to px1 equals 0 on times the conditional probability of x2 equals 1 on the condition of x1 equals 0. So plus px1 equals 0 or x1 equals 1 times the probability of x2 equals 1 on the condition of x1 equals 1. So because event x1 only have two cases, so one case is equals 0 and one case equals 1. So from the Bayes theorem we can construct this formula. So from the statement of the statement of this problem, we'll know that this part is equal to 0.2 times 0.4 plus. This is the converse of this problem. So this is 1 minus 0.2 equals 0.8 times 0.7. So this is 0.08 plus 0.56 equal to 0.64. So we successfully solved this problem. So for the second part of this problem, we want the probability of event x3 equals 1. Similar to the solution of the first part, we also use the Bayes theorem, so it is equal to x2 equals 0 times px2 equals 0 on the condition x3 equals 1 on the condition of x2 equals 0 plus px2 equals 1 times px3 equals 1 on the condition of x2 equals 1. So from the conclusion of the first part, we know that this part is 0.64, and from the statement of the problem, we know that this part is, let me see, this part is what? This part is 0.4. And this is the converse of the event x2 equals 1, and it is 1 minus 0.64, and this is 0.36. And similarly from the problem, we know that this is 0.7. So this is equal to 0.568. So we know that the probability of event x3 equals 1 is 0.568. So the third part of this problem is a little bit difficult. What we need is the conditional probability of x1 equals 0 on the condition of x3 equals 1. So from the definition of conditional probability, it is the joint probability of x1 equals 0, x3 equals 1 over px3 equals 1. So we successfully get the nominate part from the problem 2, and this is equal to 0.568. So what we want is this part, this denominate part. So by the definition of joint, the probability, it is equal to px1 equals 0, x2 equals 0, x3 equals 1 plus probability x1 equals 0, x2 equals 1, x3 equals 1. So similarly, from the Bayes theorem, we can compute the formula of joint probability from conditional probability. So it is equal to, and this is the chain rule. I think chain rule. The probability of the joint distribution is px1 equals 0 times px2 equals 0 on the condition of x1 equals 0 and px3 equals 1. So this is just px201. So actually it should be x1 equals 0 and x2 equals 0, but in this problem this is a Markov chain and the next state only depends on the former state, not all the former states. So it means that pxk plus 1 only depends on pxk and it has no relation with px1, x2 to pxk minus 1. So we can denote this part like this. Plus px1 equals 0, px2 equals 1 on the condition of x1 equals 0 times px3 equals 1, px2 equals 1. So from the problem we know that this is equal to 0.2 and this is equal to 0.6 and this is equal to 0.4 plus 0.2 times 0.4 times, and this is 0.7. So we'll know that the joint probability is 0.104. So then from the formula star we know that the conditional probability is equal to 0.104 over 0.508. So it is approximately 0.265, and we already solved this problem. So for the first part of this problem, what we need is the limit of the probability of x and n to the infinity. So like this, n to the infinity, the probability of event xn equals 0. Equals what? So this is what we want. So firstly, we will formulate the iteration like this, and it is equal to pxk plus 1 equals 0, and this is from the Bayes theorem. Pxk equals 0 on the condition xk equals 0 times pxk equals 0 plus pxk, so this is k plus 1. K plus 1 equals 0 times pxk equals 1 on the condition of pxk equals 1. So from the problem, this part is 0.6. So like this, 0.6 and times pxk equals 0 plus, and this part is 0.3. So this is the definition in the problem, in the statement of the problem. So because xk equals 1, xk equals 1, it's the converse of xk equals 0. So it is equal to 1 minus the probability of xk equals 0. So simplify this formula, we will get it is 0.3 times 1 plus the probability of xk equals 1. So if we let k to the infinity, so this formula will becomes the limit of k to the infinity of pxk plus 1 equals 0 times 0.31 plus the limit of k to the infinity pxk equals 0. So when k tends to infinity, these two parts are the same. So if we assume the limit we want equals a, this is a constant, this is the limit of this this series xk, and this is the limit of this series. So the formula star can be rewritten as a equals 0.3 1 plus a. Then solve this equality, will get a equals 3/7. So we already solved this problem, and we know that the limit of this series is 3/7.